Okay. So it's a hard one today, and I'm feeling pretty good, so let's hopefully get this. Max dot product of two subsequences. Given two arrays, nums1 and nums2, return the maximum dot product between non-empty subsequences of num1 and num2 with the same length. Non-empty subsequence. So it doesn't have to be, it has to be a sequence, but it doesn't have to be contiguous. Subsequences and array is a new array which is formed from the original array, but deleting some can be done with the characters without disturbing the relative scope. So 2, 3, 5 is a subsequence. 4 was deleted, 1 was deleted. Okay, so the maximum dot product. Okay, so dot product is just the sum of the multiplying correspondingly position values within those two arrays. So it has to be the same length, right? Yep. So 2, 1, negative 2, 5, 3, 0, 6. I think it looks like maybe multiplying the negative 2 and negative 6, the 3 and the 2. 2 times 3, negative 2 times 6, yeah. 3, negative 2, 2, negative 6, 7. So you could do 3 times 7 is 21. You could do 3 times 2 is 6, and negative 2 times negative 6 is 12. So 6 plus 12 is 18. 21 is the biggest one. Negative 1, negative 1, 1, 1. Okay, so this one can't avoid getting a negative, but can't avoid getting two negatives. So just negative 1 times 1. Interesting. Interesting. I feel like this is dynamic programming. I said that a bunch of times before. It is appropriately sized for dynamic programming. 500 is pretty reasonable length. I mean that, or it could be squared, quadratic. Definitely not linear, because it was linear, then this this thing would have like 50,000 length rather than 500 length. Yeah, I feel like this is probably dynamic programming in the same fashion. Can't sort it, right? Must be remaining in the order. So if it was dynamic programming, so if I imagine a matrix 500 by 500, where each array region is 500, I could maybe treat it as, that's probably quadratic actually. So I could treat it as multiplying the first array, the first value with everything, I guess with everything from that point and on. With dynamic programming, I should be thinking about states somehow. States, what are the parameters of each state, and then what is the transition between states. So I think, so dynamic programming here. So the state information needs to be like the index, let's say array 1 index, array 2 index, the maximum product, maximum dot product up to those indices. Something like that. So the state should have some parameters, some inputs, and then some output. I assume the maximum dot product is the output and the inputs are the indices that work. So I have example 1. Example 1 where it's 2, 1, -2, 5, and 3, 0, -6. What do I do to process it? So I go 2 times 3, that gives me 6. And I guess I could transition. I can transition by going up 1 on the array 1 index, or up 1 on the array 2 index. So I could multiply the first here and the first there, 2 times 3. I could also skip 2 times 3 and do skip 3 and go to the next index here. So I get 2 times 0. So I don't. Interesting. So the indices represent the latest index that hasn't been used. So 2 times 3, so I can skip both. I can go. Well, that makes sense to skip both. That seems like too many transitions at once. So I can use both. So 2 times 3 gets 6. And that transitions index 0 to 1 for both arrays. I can alternatively just increase the index by 1 and not change anything. So I can transition to, from index 0, 0, where 0 is array 1 index, it currently maps to 0. I can transition that to 1, 0, 0, 1, or 1, 1 if I use both, and 1, 1 become 6. If I transition to 1, 0, then I haven't really, I'm basically deleting that from the subsequence, because I haven't used something from the other side. So this would be still 0, 0. This is a stack. How would this work? Let's see. Transition from 0, 0 to 1, 0, 1, 0, 1, 1, 1. Could iterate over all possible index 1 and then iterate over all possible index 2. I think that's a little inefficient somewhat. There should be some way to iterate over these input states efficiently. 0, 0 goes to 1, 0, 0, 1, 1, 1. So cube. 0, 0 goes to 1, 0. 1, 0 could technically go to 1, 1 as well. No. 1, 0 could go to 1, 1, sure. Skips the whatever is at 0, that would it make sense to? I don't think so. Maybe I have a set of things that are a set of tuples for the states that are currently in the process stack, process queue. So if I have 1, 0, and it transitions to 1, 1, since I maybe have some sort of set that checks but not 1, 1, so I end the queue. It's possible that goes backwards. 1, 0, 0, 1. My process is 1, 0, it can go to 2, 0. Go to 1, 1, 1. Go to 2, 1. So add 2, 0 to end of the queue. It checks and sees that 1, 1 is already in the queue, so it doesn't do that. Adds 2, 1 to the queue as well. And then processes 0, 1. And process 0, 1, 0, 1, and 0, 1 go to 1, 1, 0, 1 could do 1, 2. Okay. Maybe it should be a matrix, a Boolean matrix, rather than a set. Yeah, so let's say I have, I'll visualize this with rows and columns. Maybe the nums1 is the rows, and the nums2 is the columns. It becomes 1, it becomes 2. I think this should probably be something like an added matrix rather than a set to check if something's already been done. I guess this should probably be false. Is it false like this? Like Python syntax. It's horrible. Okay, false times the number of columns for each row. Let's go ahead and just put added and see if this works correctly. I think that's the correct syntax. It is not the correct syntax. I want this to be its own element. Okay, so nums2, so num1 is the number of rows, so there's 4 rows and 3 columns. So it should be 4 rows of 3 values. I think also dynamic programming apparently will use +1 on whatever things, size of the stuff that tracks. Maybe it makes sense to do +1 here actually. Maybe not actually. This one maybe is not the place for it. So I think I do need a largest kind of an answer matrix, max matrix, which is the maximum dot product up to a certain index for the row and column. So I think this should probably be like negative infinity times columns +1 maybe. or even in range of rows plus 1. So the inputs, which are the indices to the matrix, and the output is just the value of that index within the matrix. Okay. I need a deck here, rather than a queue. And the deck will just be tuples of those indices. Process deck of tuples with 5. And I should be results. I don't think we can give a tuple into it then. Oh, to initialize a billing queue. And then something like while def. This is gonna first take the row and column. So row column is equal to the top of the deck. And then it's going to try a transition. Right. So it's going to get whatever value is currently the maximum product up to these indices. Current max is going to be max matrix at this row and column. Yes, max matrix at the first one should be 0. Max matrix at up to the first index in both arrays is going to be 0. And then it should do something where it updates 3 spots. So there's going to be 3 transitions. So we could either skip, actually let's just do the process. So let's say the one option is going to be to I guess this option should only recur if they're both multiplying negatives, both positives. Yeah, I just be brain dead about this. Use array at row, let's say array 1 at row times array 2 at column onto current total. So it'll be something like, I want to use this. I wonder if I actually need, maybe I can't make it 0. Because it actually doesn't start 0, does it? Because I can't delete everything. Maybe that's just a special case that I should worry about elsewhere. Like, I guess the default answers. Yeah, I guess I'm starting this here just and given the possibility that this this algorithm actually will remove all elements from both arrays and get 0 for like example 3. Like it would normally, if it was possible to have an empty subsequence from nums1 and nums2 to multiply to get the max product, max dot product, it would give you 0 there. I'll just handle this separately because this is handling that kind of edge case where you're forced to do suboptimal singleton multiplication is not what the algorithm I'm thinking of is going to do. It'd make it too complicated. So yeah, so it's gonna just apply this line there. So current max up to this point is that. Let's say if I do the product here, it's going to be nums1 at row times nums2 at column. And then it will be if current max plus product is greater than the value that I'm currently storing at the next state, which is going to be row plus 1, column plus 1. And then max matrix at row plus 1, column plus 1 is going to equal max plus product. Otherwise, I'm going to, I guess that's it. I guess I need to, do I need to add that right now? I could add 1, 1, yeah. Like 0, 0, I could add 1, 1. I should add the two other ones first. I should add the 1, 0 and the 0, 1 before I add 1, 1. This should be option 3. So the first two options is option 1, skip value at row and array 1. So that would push. So if the current max is greater than max matrix at row plus 1 column, max matrix at row plus 1 column is equal to current max. Similarly, if current max is greater than max matrix at row column plus 1, max matrix at row column plus 1 is equal to current max. That's the other option, option 2. I need to check to see if these are already in the deck. If we added row plus 1, if this should be not, if not added, row plus 1 column, and added row plus 1 column if it's true, and then the def appends that tuple. And then here, if not added, row column plus 1, added row column plus 1 is true, def appends row column plus 1. pushes it. I do the same thing here as well, I guess. If not added, row plus 1, column plus 1. Added row plus 1, column plus 1 is true. Defense row plus 1, column plus 1. There's parentheses there. Okay, I think this is not going to work with the edge case correctly yet. If the row is equal to the number of rows or the columns equal to the number of columns, that's probably, there's no transition there. Because that means you're at the end index. So I think maybe I should have if row equals rows or column equals columns continue. So this is at n indices. State. And the cookup is just going to return the last thing and do it. Well, this is going to be returning 0 possibly. Let's just double check this. That's what it returns. So it might, if assuming it doesn't crash, oh, it's going to crash. Out of range. Out of range. Added row, column plus 1. So if I have a size 1 for both arrays, starts with 0, 0. Added should have 0, 0. I see, yeah. It does need this plus 1. Nope. Oh, this is surprising. This is the one thing I thought would definitely not work. Interesting. I thought that one would be the one that actually goes to 0. What's going on there? Max matrix at 0 is going to be 0. Put max is 0. Thought that would push 0 all the way to the end. Negative infinity. Alright, let's go and just do a quick sanity check here. Zero, zero, zero. I see. Yeah. No, I don't see actually. So why didn't you just push 0 to the very end? Zero, zero. Yeah, it's negative. Ow. How did negative 1 get there? I think I see it. Okay, let's do a test case here. Let's say it's negative. It's between getting -2 and -3. Or -2, -3, and -4. The answer here, if it does it correctly, is going to be -2. I think. Okay, so it doesn't do it correctly. It's -3. I understand why it might do that. I think it. Do I understand why it does that? Yeah, it's getting like zeros everywhere. It's getting zeros everywhere, and then if it gets 0 everywhere, then at some point, sure. Interesting. I think I'm not handling the side cases correctly, actually. Yeah, I'm not handling the side cases, actually. I don't think this is correct. Can't just skip. I think you need to push it to the. I think you need to push it to. You need to push it in the direction that's possible. So I think this is just this. So you can't do it if the row +1. So I think how to do this? Row +1. Cut max. So if you're at the edge, you're still within bounds. Okay, so I think this means skip value 1 in row 1, assuming that this is not more than maximum. So maybe this should be something like if row not equal to rows with column not columns. And this would be if you're not at the very last, if you're not on the edge here. So this should be like if row not equal to rows, then column not equal to columns. Then you can do option 3. Maybe that works. Okay, so this does push the 0. Good. Okay, so the one case where I was pretty sure it should fails now. Now the other cases. What is going on here? When does 3, 2? I think I should be pushing. pushing a 6 here. 3, 2. Product of nums1 at 0 is 2. Nums2 at 0 is 3. 6 plus current max is 0, so 6. 0 plus 6 is greater than negative infinity, I think. Oh, what happened here? Why didn't... oh, somehow I commented out this line. I don't know why. Oops. Okay, good. So the first... Actually, I'm not sure why. Okay, yeah, this is... That's doing that correctly. Now it's just handling the last part. So return value, or let's say answer, equals max matrix at the last. If the answer is equal to 0, then I need to verify either multiplying the two biggest positive numbers or so if it's 0, then either then it can't be 0. These values, okay, yes, it can be 0, but it's only 0 if basically everything is negative. So if everything's negative, then I need to pick the smallest negative from both. So the maximum array one has to go to, I believe. That would be correct. That would also work if there was a 0 in those arrays, because the 0 would be the maximum of those arrays. Otherwise, return the answer. Array 1 is called nums1, nums1, nums2. Oh, diggity. Unfortunate. Oh. Yeah. Huh. Interesting. So what is the minimizing value here? So yeah, oops, this is if it's negatives, then that means all the values in one array is negative and all the values, or non-positive and all the other values in other arrays non-whatever, non the opposite. So like one's positive looking, one's negative looking. So I think I need to return, so it could be the max times the min, I guess. The larger of those two. The maximum of max of nums1 times the min of nums2, min of nums1 times max of nums2. Okay, this should work. Nums is not spelled correctly. Okay, so just remove the comment as the prints. And I think that might be it. Alright, let's see what crashes on. Okay, interesting. Not fast enough, huh? Interesting. Guess I don't need a matrix to. Do I need a matrix? Do I need a deck? Just use it for each loop, or nested for loop. For all the indices of the outer loop, for all the indices of the row, for all the indices of the column. Actually, that might be workable. Yeah, okay. This is the processing order. So if I go through it's 2, 1, maybe 2, 5 is the row, and the columns are, I guess I'll put it here, 3, here, and number 6. Yeah. Can just do for each loop for all the indices, I think. Yeah. Alright. Lesson maybe learned here. In which case do I need? I think I need a singleton column. If I'm going through every row and every, I guess I need a singleton row. This row and the next row, maybe. So I process for every row and then every column. So I'm processing here, then here, then here. I'm processing A, B, C. And while I'll do A transfers to B. A transfer to B. Yeah, A transfers to B and A transfers to D. A transfers to B. A transfers to D. B transfers to C. B transfers to E. Alright. What can I keep? I think I can probably keep that. Variables, rows, and columns. I think I need current row is going to be 0 times the number of columns plus 1 maybe. And next row, next row is initially 0 times the number of columns plus 1 maybe. For every R length rows, for every C in range columns. So from a current row and column index, then I'll get the maximum. Max is equal to, I want to say current row at this column. And then at some point after this loop, I think I need to do something like next row equals current row, or current row equals next row. So I'm going to fill in the stuff for the next row as I process the current row. I think. So the current row and column is 0, 0 are the indices. So then it'd be right. I can do 2 times 3. So I can do something like the product. Right? Product is equals to nums1 plus row indexes are times 2 of this column index. And then I can do something like, if this is bigger, if the current max plus the product is greater than current row at c plus 1, and current row at c plus 1 is equal to this product, or this current matrix product. So this is the option 3 where I actually use the values of both indices and apply that to the total dot product. And then I need to do the other 2 options. Let me do the other options before or after this. So skipping, oh whoops, this is not right. This should be at the next row, isn't it? The next row should be that. I mean, the next row should always be, so I'm filling, so if I have this, I'm taking 2 times 3 and 6, I should get this thing. I guess that should automatically be there. There's no way that's going to be filled before, right? Yeah, so I don't think there should be anything there right now. So I think it doesn't need an if statement, I want to say. Yeah. So this should be the next row. That's going to be the default. And then the other options would be to skip. So if the current max is greater than the current row at the next at c plus 1, so skip the nums2 value, then current row at c plus 1 is equal to the current max. And then if the current max is greater than the next row at the same column, then the next row at the same column is equal to current max. That would be right, actually. Zero, zero. So all this goes away. I'll actually just copy and paste this. Answers the last value in the last current row equals next row. So I think it's just going to be the last value in the current row. All right, let's see if this works at all. Probably crashes. Ooh. Ooh. Not so great. Interesting. -9 is adding them up somehow. All right, let's see what's going on here. That's the -9. So I start with zeros. Maybe I should be starting with negative infinities, to be honest. Actually, the current row should start with 0. Row 0 should start with 0. At the very least. Nothing is changing my answers. -9. Interesting. Let's go with printing out the row at the very end. -4, -6, -9. It's just adding them up. Next row at C+1. Interesting. Okay, so let's see if I can't parse through what's going on here. All zeros after the first pass. Really? Guess that makes sense. Because you're basically skipping, so you're going 2 versus 3, you're skipping 3s, versus 0, you're skipping 0, versus 6, you're skipping, so you're getting 0 all the way to the end. And then if you're not skipping, then if you go 2 versus 3, you get 6. 2 versus 0, you get 0. 2 versus -6, you get -12. Okay, I understand that. Now this is your current row. So you go 1 with 3, 1 with 3. That gives you 6. So now 1 with 3, you get 3. So the current row should be 6 here, I think. One versus 3. And it should be 6 right there. You should be comparing 3 versus 6. What is going on here? max. No, I'm doing this wrong. 0, this should be 6. Cut max is greater than and just print this out here. So, okay, so yeah, it's 0, 6. Yeah, so it's 0, 6, 0, 12 at the start of loop 2, the second loop. So the current max should pull 0. Product is whatever. It's like product should be 1 times 3 maybe. Product should be 1 times 3 should be 3. So 3 is compared to row C plus 1 is 6. Should be false. Feels like doing something very wrong. Cut max. So the cut max here is 0. This value is bigger than 0 is not bigger than 6. Oh. Oh my lord. I need to actually toggle the references. That's so stupid. Oh my god. Okay. Still not correct, but hopefully this is better. Why did it push a negative? What the hell? Start was 18 here. Oh. The answer should be using next row. What reference should this be using here? The answer is 18, which is actually 21. Am I using the wrong row? Current row equals next row. After loop, next row. What happens at the final row? Final row. So I'm pretty sure that what I need to do is say this is next row. I'm not sure why the logic there is. This should be next row. So when it does this last row, pushes it to the next row, and the next row becomes the current row after the loop. The next row becomes the current row. What is going on? So if there was just one pass, if there's just one row, then the current row does a pass, builds in the next row, okay. I think I see. Do I see it? Do I see it? So this thing here, this thing, this thing. Okay. Yeah, I think I see it. The current row is actually there. I don't know. If it's I wonder. I don't think this is right. Actually, if I change this, it works for these test cases, but I don't think this is right. I think I can come up with a test case where this is wrong. I think it's probably assuming that you're not going to use the last pair. But I think if you have a test case where you are forced to use the last pair, then it's wrong. Something like this, I think this fails. Oh, what? Let's say 1, 2. So the answer here should be 3 plus 12, so 15. Interesting. Okay. Let's go ahead and just put both. I think I might need to use the biggest of the two. Yeah. So the answer should be the maximum of these two. I think that's probably correct. Oops. Maximum of the largest, or the last of those. All right, let's see if this is faster than me. Let's see if it works. It might not. Okay. 28, 16. So it should be 5. Should probably do -4 times -4, -3 times -4. 16 plus 12. But it doesn't. Interesting. Alright, I guess I should probably just do the prints. Five, 4, 3. Alright, so the first pass, the row is 5, or the row value is 5. After the loop, yeah, it's going to be all zeros because it doesn't really. So yeah, it's going to push zeros there. Oh, it's going to push zeros here, and it's going to push zeros there because it's going to skip multiplying 5 by any of these. Except the last one, 5 times 2 is 10. Okay, so in the second pass here, -4, we should try to multiply -4 and get 16. Times -3 is 12. Times 0, 0. Times -4 is -16. Times negative times -4 times 2 is -8. Oh, interesting. The answer is in this spot. I wonder if it's just an indexing issue. I should be indexing the last of the current row and the second to last of the next row because this spot is actually kind of like garbage, I think. Because this is the actual below the last column. I don't know. Maybe I need to index all 3 spots. This spot, and this spot. So it should be like current row -1, next row -1, next row -2. Actually, which one is next? Current row. No, let's go. I'm quickly losing my ability to solve some of these logic issues. So it should be the last 2 of the current and the last one of the next. So max of current row -1, current row -2. Okay, I think, well, this should solve this particular error. Not sure if it's fully correct. Feel like it's might be. Oh, vain hope. Okay. Let's see if I can't figure out the actual issue here, or if it's another issue. The answer should be 50. So it should be like 5 times 2 is 10. 3 times 4 is 3 times 5. 3 times 5 is 15. 5 times -5 times -5 is 25. So there's just 10, 15, and then 25. So that should add 50. Okay. So what should it do here? So the first pass, we should get 10 and 25. So multiplying -2 times -5 times -2, -5 times -5. Second pass, 3 should skip Should do. Three times -2. 3 times -2. Okay, yeah. Okay. I'm figuring out what my code does on the fly. So somehow I did get 50. Somehow I did get 50. I don't think it pushes it correctly. Why does it push that one correctly? For every column, for every row, so it pushes to the side. Yeah. Okay. I think it needs to go through C columns +1. Actually, okay, so it needs to actually do something like next row at C+1 is equal to the max of the current row at C+1 and the next row at C+1. I think that's, I guess C is just actually false. It doesn't push that thing correctly, I guess. Don't recall ever having to do that in previous dynamic programming. This is probably, I don't know. Now this thing goes back to being interesting. Wonder, does it push the last one? This is the next row. This is the current row, which is the next row. I wonder if this is actually anything. I think the last part, which was what? I guess maybe that was pretty necessary. Yeah. Let's see what the next error is. Gosh dang it. This is sad. Maybe I should have stuck with my original solution that was slower but more correct about errors. Fudge me. There's 200 right there. So does it push the last thing? Alright, fine. You know what? I think it should be just the maximum of the current row. Okay. Alright. You win. Oh. Oh my god. That was, if I had done this 30 minutes ago, that would have felt pretty good, but after 30 minutes of, at least 30 minutes of errors, this feels pretty rough. I actually still don't fully know why there was a need to, what's happening with the current row there. So it's like doing this last row, pushing the values here. I guess that just means that you can skip from that to the skip from whatever last product that you do to the end, but you didn't actually process that. Okay. Kind of get that. Yeah. Okay. I'll say here. This. So it's E, F, G, H, I, and J, K, L. And this is initially, current row is initially like A, B, C. And next row is initially, or after the first pass is going to be F. Alright, so the summary here is going to be original solution used classic kind of dynamic programming matrix, where the state input variables, which is the nums1 index, which I use as row, and the nums2 index, which I call columns, which I call the column. Mapped to a output value, which is the maximum dot product obtainable up to those indices. The transition between states represent what could happen when reaching index, let's say R and C, in those respective arrays. So there's going to be three options. Option 1, skip R. Option 2 is skip C. And then option 3 is to use R times C in the total product. So yeah, I don't have that. I guess. So what was it? That was 40 minutes ago. So yeah, this is option 1. Skipping the row. You can do that as long as you're not at the maximum row index. Initialize your matrix to be kind of 0 at index 0, 0. This means that your maximum product starting is going to be 0. But otherwise, we have negative infinity elsewhere in the matrix just to ensure that it's going to be higher. I guess it could be 0s at those spots as well. Yeah, it probably could be 0 there. Unfortunately, the processing there was a bit slow. And when using a depth of tuples to determine which row column to next process. So the second solution after many bug fixes is more efficient at the cost of comprehensibility. Let's call that word comprehensibility. Comprehensibility. There's no A there, is there? Comprehensibility. What is that? This thing crashed. What is going on here? Alright, it's more efficient to cost comprehensibility. Basically converts or exchanges the matrix storage of the partial answers or the temporary answers into two arrays, basically the current row of values and next row, and iterates using a nested for loop over the row and column indices. Does the same transition calculations on those values, and returns the largest answer found within the last two kind of arrays with partial values. Also, both solutions assumed that it was possible to skip every kind of every value. So I have empty subsequences. So there's special handling for that edge case. For the edge case or special case, like in example 3, basically if the answer from that would be 0, above algorithm would be 0. Triggers calculation based on the special case, which is the multiplying kind of the smallest times largest of each array. and taking the larger value. So that's the special handling there. If the answer is 0, that could only be, that can't really occur if you have kind of non-zero, non-empty subsequences, or non-empty subsequences that have 0 within them. So, like it would only occur if your calculation just pushed a kind of a default 0 product all the way to the end, because everything else is going to be giving you negatives. And that occurs basically when you have a negative array, the values times the, or as 1, and then a positive array of values. So the best thing there is just to take the smallest negative times, or the smallest negative times the smallest positive, or the smallest positive times, or yeah, the smallest negative times the smallest positive, but depending on which negative and which array is negative positive, it's going to be either the maximum then. In any case, time complexity is O of this is definitely O of mn, where m and n are the size of the numbers array, or the size of the numbers array as it iterates over each index and does some work on them. Time complexity O of, okay, this is like O of m or O of n. Since just 2 arrays full of the columns, size of the columns, basically nums2, are needed to store the temporary kind of product values. Oh boy, this was too long. All right. Well, got somewhere.